So welcome all. In this video, I will explain the complexity of the software system. We will first look at the fundamental concepts and that will help us to understand the object-oriented programming principles in the next particular videos. So I want to first add, or we can say I want to first talk about the purpose of the software. So what is the purpose of the software? Why do we write the software? This is the most important question, right? So we write software to perform some complex tasks or complex calculations. And this is the complexity, and obviously that also reduces human interventions, and that will lead to lesser chances of errors. We also write software to perform some repetitive or monotonous work, and obviously there could be other reasons as well. For the purpose of the software, the next question is developing software complex, or what do you think? So basically the answer of this particular question is yes, developing a software is complex. So writing the software is complex. So let's understand this in a depth. There are so many things in this world that exhibits great complexity. For example, beating of heart, or we can consider photosynthesis process, or we can consider here weather patterns. All these are complex things and cannot be understood easily. The same thing applied to the software as well. Imagine database system that has to maintain the integrity of thousands of records, or a financial system that has to process millions of transactions in a minute. Or what about an air traffic controller that has to manage too many different planes that have to take off or land at an airport? It so happens that this complexity is too great for one person to understand, and it is very difficult to completely eliminate the complexity from the software. But what we can do is we can try to reduce it. So, before we see how the complexity of the software can be reduced, let's understand the reasons for the complexity of the software. So, one reason is the complexity of the domain for which the software is written. Some domains are complex, such as finance, telecom, etc. The complexity of domain automatically links itself to the software. And then there are non-functional requirements for the software, such as usability, performance, cost, like that. So these also add the overall complexity of the software. The other reason is the communication between the users and the developers. Usually the users have a vague idea of what they expect from the software, and they may also find it difficult to express their requirement to the developers. And usually developers expect requirements to be in the specific format. Say, for example, they want the requirement to be specified in the UML format, where they expect use cases, class diagram, interaction diagrams, like that. And that's not at all. So it may happen that the users and the developers both may lack the experience of the domain, and sometimes the user gets better idea of the system only after they look at the prototypes or their design documents that are they have created later. And until then, the software may have been already developed up to the some point. Therefore, when the users gets a better idea, they are required for the change in the software, and that change may be difficult to incorporate in the existing software. So obviously that leads us to the next reason for the complexity of the software. That is the volatile nature of the requirement, and the requirement always keeps on changing. If the requirement changes, and that changes needs to be incorporated in the software. It may be difficult to do that, and may be possible only if the developers have kept a provision to accept that change. That is why during the design of the software, the future changes, how to anticipate it. And obviously, this is difficult things to achieve. The other communication reason for the complexity of the software is unpredictable behavior of the software, where it is running on the computer system. So the software runs on a system which have thousands of discrete components, and these components will have their own discrete states. Okay, so and when the application is running on such a system, it may have multiple threads running at the same time. Thousands of variables may be allocated happening on the stack or the heap, and therefore this will lead to the large number of events and states in the application. And the combination of these events and states along with the state of the discrete components will lead to a combinational explosion, and it is difficult for the developer to predict the outcome when such a large number of events and states are involved. It may also happen that the external event may cause the entire system to fail just because of the developer fail to anticipate the outcome of a particular interaction between the event and the state. The other reason for this particular development process is nothing but it is difficult to manage overall development process of the software. The reason is the most software is written by teams, and it may be possible that the team are spread out on a different geographical location, and this may leads to problem of the communication and coordination between the developers. And obviously, when the number of developers increases, the communication becomes more complex between them. And this problem may also be aggravated by the fact that the sum of the resources may live in the between the developmental process, leading to the resource storage. So I have explained some common reasons for the complexity of the software. Let's just quickly summarize that we have talked about. So software is used to solve the problem, and it reduces the complexity, but writing the software itself is a complex basically. And the reason for the complexity for the software are the factors such as complexity of the domain, the changing nature of the requirement, or unpredictability of the software. So in this particular next video, we are just want to talk about how to reduce the complexity of the software. So welcome back to this particular session where I can we consider here object-oriented analysis and design. In the previous year, we have discussed the complexity associated with the software, and we also realized that it is impossible to completely remove the complexity associated with the software development. But we also know that even though it's not possible to completely remove the complexity, but we can at least try to resolve it. And that's why we are going to learn, which is going to, I'm going to explain you in this particular video with the help of the object-oriented analysis and design. Just a minute, student. So in this particular part, I'm going to explain you algorithmic decomposition. So human being has built a mechanism through which we deal with the complexity. We decompose each part of the problem into smaller part, and we keep on doing that until each part makes sense individually. And finally, we take this individual part and then integrate them together and then solve the problem. So when we consider this point, the programming language, we integrate the different parts to build the system basically. Okay, so this is based on the principle of divide and impera. So typically it will start the top-down approach where we start with a big picture, which break down into smaller chunks, and these steps leads to the final result, which like a flow chart. So what exactly it means, divided imperial? Divided imperial, that means it is a Latin for the divide and rules. This principle was used in ancient Rome to conquer the neighboring states, and obviously the same principle is to be applied for our programming language, where we can resolve the complexity, is also known as algorithmic decomposition. So basically in the algorithmic decomposition, so basically in the algorithmic decomposition, what happens? So that we have to consider in this slide. So in the algorithmic decomposition, the problem is decomposed into algorithms, and each algorithm is a part of series of steps, and that steps are the part of some overall process. So basically this is similar to the top-down approach, in which we start with a big picture and then that is broken down into smaller chunks. It is much easier to deal with the problems in smaller chunks once the solutions are created for a smaller chunks. So this leads to the final result, and it is just like the flowchart approach. So you have to consider here the number of steps in which there is begin and end, and the intermediate step solves the problem. So let's understand this with an example. So let's try to understand this with an example. Okay, so let's assume we want to develop a software that helps the tutors in a school to prepare a report card for their students. This software will accept the student details, the test details, the marks in the subject, and then finally it will calculate the total score. So the average score, and then it will be assigned the grades based on their true score, and it will be also display the subject in which the student has scored lowest and highest mark. So let's apply the algorithmic decomposition to this problem. So what we want is we want to prepare a report card, and this is the big picture that we have. So we will decompose this. So for the software to prepare the report card is needs data. That's why the first thing, if we have to accept the data from the users, once the data has been accepted, it will be used to perform the calculations, and after the output of the calculation will be get displayed. So this is all about the things which will be required. Okay, so now these steps can be further decomposed into multiple steps because these three steps are too generic, they are too big. It will make sense and decomposing them into smaller steps. So these are the final steps that we can do. So we'll first input the student info, then test info, then the student subject info, and then we'll calculation will be get performed. After the calculation, the grade will be get assigned based on the marks. Once all the data is ready, that will be displayed to the users. And these are the final individual steps in the more detail. So we will first take the input. So we'll first take the input. We will accept the information about the student, the information about the subject, and the information about the test. So the information about the test would be that will be information about the semester, the kind of test, etc. And once all the data is available, the calculation will be performed. And finally, the grades will be assigned once the data is ready. That will be displayed to the users. So you can see this is all just in like executing a steps of series. Now this approach may work for a smaller application, but it is not suitable for the large scale software development. The first reason is the development that is based on the algorithmic decomposition is based on the high level specification, and we know in the software development the requirements of the client often changes over the time, and that causes some part of the software to be rewritten. This means we have to integrate the new changes into existing software, which is very complex process basically. So the other things is that the algorithm that we have already written, they are very specific to the application. Therefore, that makes it difficult to reuse. And for the same reason, because the algorithms are specific to the application, they are tightly coupled with each other. Therefore, it is difficult to add new features. What about the data? Let's consider first this point that if the data is not given, what about the data? Is this kind of application, the data is not given much importance, right? It is treated with low significance basically. So this means if several algorithms require some data, there is no safe way of sharing the data only with those algorithms. Instead, the data is available globally. That means every algorithm can access any data. Instead, the data is available globally. That means every algorithm can access the data. And because of this, some unintentional modification of data can lead to this disastrous results. That means it doesn't give me any proper result. One important thing about the algorithmic decomposition is that it focus is only on doing the things. That is the focus on the operations. So we don't have any idea about the entity on which the operation is performed because that is not represented in the algorithmic decomposition. And therefore, the overall understanding of the application becomes complicated. It becomes difficult to understand the working of the application because it just executes as a series of steps and the system does not map to the real world problem that is trying to resolve. The initial programming language were created for solving scientific problems basically and performing mathematical calculations. The system based on these languages which grew in the size and complexity, and the programmers realized that these languages do not address the problem associated with the reusability, scalability, and maintainability. And therefore, a new way of resolving complexity was required, and that's why we are using object-oriented decomposition came into the picture. We are going to discuss this object-oriented decomposition in next session. So basically, these are the languages which are based on the algorithmic decomposition. You can see in this slide. So in this system, based on the languages, there is a size and complexity, and the programmers realize that these languages do not address the problem associated with the object-oriented decomposition. And that's why we are going to understand what exactly the concept is given by the object-oriented decomposition. So this is overall summary I have explained here. So far, we have discussed how humans deal with the complexity. We try to resolve by breaking down the problems into smaller chunks, and that is known as algorithmic decomposition. But with the algorithmic decomposition, the focus is on the operation rather than data, and that's why data is not secure. Also, the application implemented through algorithmic decomposition do not scale well, and they also do not map to the real world, which making it hard to understand and maintain so that it is so far what exactly it is to be given. So now let's understand object-oriented decomposition. So in this particular video, I have explained you the object-oriented analysis and designing programming. So in this video, we will discuss how algorithmic decomposition can be used to resolve the complexity, but we also realize that it is not well suited for the large-scale software development where we needed extensibility, reusability, and easily maintenance. So in this video, we will discuss about object-oriented decomposition, and we will see how it is address the shortcomings of algorithmic decomposition in this particular algorithmic decompositions. So we use the principles of divide and rule. So we break down the system into smaller chunks, and that's how we resolve the complexity. But now there is another way through which human deals with the complexity, where we can abstract the complexity and focus only on the necessary details. That means the details that we do not need are ignored, but we deal only with those details which are relevant to us in our domain. The result of this is that it leads to the simple entities of the problem, which domains takes place. For example, I'm taking here an example that cell phone. A cell phone is having made up of many components, right? Which is very complicated components. So then we can go to the buy a particular cell phone. What exactly, where we only focuses on those details which are more important important to us. So for example, what kind of operation the operating system it is iOS or Android, then how much storage it has, then what is the battery backup, what networks it supports, or what the screen size, or what is the resolution of the camera. So but there are some complex details as well. For example, what is the file system type, then what is the type of battery, it is lithium or ion, or it is lithium polymer. So then we are capturing that particular camera, or what is the field of you are looking for. So such a type of things, if I'm going to consider with this particular, say for example, I'm considering the what is the color space of the screen, like that. So all these are the complex details, but we generally do not deal with them because they are not be important to us. So the end result is that we get an object which is an abstraction of the real object with only relevant details that makes it easier to use the object in a software development, basically. So after we get the object, after we get the objects after the abstraction, then we recognize the relationship between them. Some of the objects can be generalized. That means some objects have similar behavior. For example, dog, cat, cow, all are have same behavior of it. That means we can generalize them as animals. So this further makes it easy for us to resolve the complexity. We also find out how the object interacts with each other, and this coordination between the object gives rise to the functionality of the system. So basically, it understands only the coordination between the objects. So in the object-oriented decomposition uses a bottom-up design. That means the system is decomposed as a set of autonomous but cooperative agents, and these agents are objects, and these objects represent the key abstraction of the problem domain. Each object is designed with a great details. That means each object has its own behavior, and it will be model some objects of the real world. So many such objects will coordinate with each other, and they will go rise to the functionality of the system. The coordination between the object is performed by sending a message to each other, right? So if this is a system made up of object-oriented decomposition, all these boxes represent unique object, and these objects communicate with each other by sending messages. Each object has its own behavior and data. As mentioned earlier, this is based on the separation of concerns. So that means each object is responsible for its own behavior because the object communicate with each other by sending messages. It is possible to replace one object with another object, and we may do this that because the new object may have a better implementation of a certain behavior. Now, whatever things we have done, now let's implement object-oriented decomposition to the problem that we were working on earlier. So we want to create a software for tutors, and the first things we will do is we will find out the key objects in the problem domain. So the key object would be the report card, then the student, then the test, and the subject. The student object here is not an actual representation of real life student. Instead, it represents an abstraction of the student in the problem domain. If it will not have the age of that particular student, the height of the student, because there are attributes of their real life students, right? And which is not important to us for this particular domain. So when we want to generate the report card will communicate with the student, and the student itself will not have the details. Okay, so it will get the details from the test. So it will ask the test objects to compute the average. The test object will get the marks from the list of the subject. Once it has marks, it will compute the average and also decide the grade. And all this information will finally go to the report card object, and then the detail from the report card object may be displayed on the screen, right? So you can see the object communication with each other by sending messages in the programming language. These messages are nothing but member function calls or method calls, and it is also possible to replace one object with another object. For example, if there are different kind of tests that have to be taken, then we can replace this existing test of the object with the another version of the test object. So let's discuss the advantage of object-oriented decomposition or the algorithmic decomposition. So object-oriented decomposition follows separation of the concern. That means each object has its own responsibility. Then we can address the complexity of the system by organizing the object. So we can either use generalization or we can use classification. So the system is made up of objects that represent the real life entities, and those entities make closure to real world problem. And that's not all the object decomposition data is prime importance, and it is the part of the object and it is not visible externally. That means the data cannot be directly modified by the external world. Object-oriented decomposition allows generalization of the object, and we can reuse common functionality of the same object of the some objects. So this ultimately leads to the smaller system. It is also possible for the system that have been designed with object-oriented decomposition to evolve incrementally over a period of time by adding a new and better object. So by now you must be realized that object-oriented decomposition is obviously much better than algorithmic decomposition for a large-scale software development. So let's quickly summarize the important points that we have to discuss in this particular video. That is nothing but object-oriented decomposition views in the system as a set of autonomous objects, and these objects collaborate with each other, and data has high importance but is hidden from the external world. And the object-oriented system will map closely to the real world problem domain, thus making it easier to understand and maintain. That's all. So this is all about the complexity of the system. So in this particular session, we have discussed regarding how to or what exactly we want to do regarding the complexity of the system in terms of object-oriented decomposition.